Among my many guests have been Mars Society founder Dr. Robert Zubrin, speleologist Dr. Penny Boston, astrophysicist and author Rick Boozer, and many more engineers, science fiction writers, and space technologists, as well as several of the Mars One volunteers, about whom I will speak more later. As I told an editor once, I'm not an expert, but I travel in the company of experts. This talk is intended as an overview of some of the challenges posed by establishing a settlement on Mars, but it is by no means comprehensive. And since no actual working model, such as a lunar station, exists, it is highly speculative. So as we discuss this tonight, I would ask you to consider how you think settlers on Mars will be living at mid-century. I think we're ready for slide 2, Sci-Fi. This talk is especially timely as a Mars opposition occurred this week. While it is near, I would urge each of you to take a look at Mars through a small telescope using only naked eye observation and consider the maps shown on this slide when you do. Does Mars have canals? This was a hot debate topic of the late 1800s. Several prominent astronomers, including Percival Lowell, not only claimed to see an extensive system of long, straight canals on Mars, but used them to indicate that intelligent life exists there. The relatively close opposition of 1894 was used to make drawings like the one digitally rescaled on the above left drawing. The above map was originally prepared by Eugene Antoniadi and redrawn by Lowell Hess for the book Exploring Mars by Ray A. Gallant. In more modern times, the latest Mars opposition has allowed the Hubble Space Telescope to capture a picture of similar orientation. Comparison of the two images shows that large features were impressively recorded, and accurately recorded, by the way, but that the extensive system of long and straight canals just does not exist. Satellites orbiting Mars have now shown conclusively that the red planet does indeed have surface features similar to canals, but that these are usually smaller, curved, and less extensive than previously claimed. Real canyon systems, like Noctis labyrinthus, are most likely cracks caused by surface stress. To summarize, on this slide, we see Mars as we view it today juxtaposed with Mars as it was envisioned in the days of Giovanni Schiaparelli, who lived from 1835 to 1910, and Percival Lowell, who lived from 1855 to 1916. For those of you not familiar with the story, Schiaparelli noticed some line-like features on Mars during his visual observations during a late 19th century opposition. He dubbed them canali, which apparently can mean lines or channels in Italian. Others immediately picked up on his choice of words and relabeled them canals, and the story of the canals of Mars was off and running. Percival Lowell was so fascinated by this phenomenon that in 1894 he had an observatory built in Flagstaff, Arizona, the Lowell Observatory, located high in the mountains where the air is clear and dry, which are great conditions for optical telescope observing. He subsequently made elaborate maps of Mars connecting the various large features such as the polar caps, Hellas, Argyre, and Syrtis Major, with a network of canals that he postulated were constructed by intelligent Martian engineers to irrigate the otherwise arid planet. By the early 20th century, astrophotography was coming into use, and no evidence of the canals ever showed on the photographic plates. However, Lowell and many others continued to argue that they saw canals through the telescope, and their drawings and photographs were regularly featured in publications and on geographic and geological maps describing the surface features of Mars through the 1950s. The concept of canals with flowing water on Mars was finally debunked in 1964 when the Mariner probe took close-up pictures revealing no canals. However, recent data collected by the Curiosity rover does suggest that liquid water may have existed on Mars at some time in the past, creating sedimentary flows similar to dry canal beds. The mystery of the canals, which were seen by so many trained and reliable observers, probably lays in the well-known psychological phenomenon that we see what we expect to see. That is, people are subject to observational biases, and scientists and astronomers are not immune to this problem. For example, early astronomers were mystified by Saturn when it was first observed telescopically. Having never seen a celestial object with rings, the observers at first didn't recognize them as such. Hundreds of studies have been done that demonstrate this type of bias, and I suspect that Schiaparelli fell victim to it. Once he saw the first lines, which may have been caused by eye strain or some other less than exotic cause, he expected to see more lines, and thus he did. Suggestive subsequent observers were similarly misled, and the myth of the canals of Mars and the Martians persisted for 75 years. Could we see slide 3, please? Several Earth-side simulations have been done to study various aspects of what astronauts might face on Mars. As we see on the slide, researchers from the University of Hawaii at Manoa recruited crew members for a new series of space exploration analog studies. I believe this type of study is essential for NASA and other space agencies to understand how teams of astronauts will perform on long-duration space exploration missions, such as those that will be required for human travel to Mars. The 4-month Hawaii Space Exploration Analog and Simulation, run by the University of Hawaii, Cornell University, and funded by NASA, occurred last summer. And there's their habitat there that they lived in for several months. Could we see slide 5, please? Or slide 4, rather. The Mars Desert Research Station, run by the Mars Society in Utah, is another analog project. As the slide says, the Mars Society's Mars Direct plan, led by Dr. Robert Zubrin, proposes that an empty, human passenger-capable spacecraft go to Mars first, with the robotic capacity to make fuel locally, so that before the manned portion of the mission leaves Earth, a return craft is already fueled and ready for the flight home. A long duration on Mars is part of this mission architecture, occupied on a more or less permanent basis by crew members who rotate and work on various projects. The MDRS station is being used to study the problems associated with such a long stay. Once in the station, the crew member must suit up in a simulated pressure suit whenever venturing outdoors, as well as confront the day-to-day problems that are inevitable on any such mission. Let's take a look at slide 5. Completed in 2000 at a cost of $1.3 million, the Flashline Mars Arctic Research Station, which is located at Devon Island in northern Canada, only 800 miles south of the North Pole, simulates Mars and polar desert conditions. This station has a planned 1-year mission starting next year, during which the crew will be isolated. As with the desert station, they will need pressure suits before venturing outside and will conduct experiments on an ongoing basis during the mission. All of the Mars simulation missions have completed and will continue to do valuable research in anticipating and devising strategies for successfully confronting the problems presented by life on Mars. Slide 6, please. As a hard science fiction writer of several novels and short stories on the subject, I also spent time attempting to envision what life might be like for a settler on Mars. The research for my books is based on actual mission data, and reports from space agencies like NASA, ESA, and the commercial spaceflight industry. However, as a science fiction writer, I take some liberties with adding characters and the situations I put them in. For example, most of my Mars settlers are spelunkers. While we suspect there may be lava tube-type caves on Mars, I expand this to include other caverns, including a limestone-type cave. Similarly, I include the settlers dealing with Martian dust devils as well as solar flares as a part of the Martian weather challenges they face. If any of the plans to travel to Mars come to fruition, we may well find out if my speculations and solutions have been correct. Slide 7. Inspiration Mars. There are currently 3 major proposals for missions to Mars during the next decade. Inspiration Mars is a Mars circumnavigation proposal by aerospace engineer, entrepreneur, and astronaut Dennis Tito, which for reasons of orbital mechanics must occur in 2018. He is proposing a crew of 2 for the 501-day voyage, and the mission will use equipment such as that shown in Slide 7. These include the Dragon X spacecraft as well as an inflatable habitat. That this equipment is already or very nearly operational will enhance the possibility of meeting the deadline 4 years hence. Tito has created a foundation, the purpose of which is to carry out this mission. Could we see Slide 8, please? Like many space exploration plans, Tito's ideas are based on earlier concepts, in this case proposed by Italian astronomer Gaetano Carraccio and German-American rocket pioneer Wernher von Braun during the 1950s and 1960s. Utilizing concepts in these proposals, Tito's plan calls for a January 2018 launch to Mars along an orbit that will reach Mars the following August. The spacecraft will fly by Mars, approaching the red planet at an altitude of a little over 100 miles. Then the spacecraft's orbit will continue sunward, eventually dipping near the orbit of Venus before heading outward and meeting Earth 273 days after the flyby in May 2019. Another plan I alluded to earlier while discussing the MDRS and the FMRS analog missions, the Mars Society's Mars Direct plan, promoted by Dr. Robert Zubrin, proposes that an empty, human passenger-capable spacecraft go to Mars first, with the robotic capacity to make fuel locally, so that before the manned portion of the mission leaves Earth, a return craft is ready and fueled for the flight home. Zubrin also proposes an 18-month layover on Mars that will allow considerable exploration and research by crew members, much like the astronauts visiting Earth's moon did. Such a mission would gather invaluable information regarding the planet's geological history as well as the feasibility of establishing permanent settlements on Mars. Can we see Slide 9, please? The Mars One mission, proposed by the Dutch-based Mars One Foundation, postulates one-way missions to Mars and the establishment of permanent settlements beginning in the early 2020s. To date, over 200,000 would-be astronauts volunteered for Mars One. That large group has since been thinned to 1,058 volunteers who are currently undergoing physical exams and interviews. Eventually, the astronaut pool will be reduced to 24 to 40 candidates. The ambition of this program is to forego the return trip entirely, thereby simplifying the logistics of the mission. My own view is that this is logical mission architecture to use for settlement, but only after at least 1 or 2 exploratory missions, such as Mars Direct, have been completed. Could we see slide 10, please? Unlike Earth, Mars lacks a magnetosphere to protect the planet's surface from solar and cosmic radiation. To shield astronauts from these high-energy particles, habitats and workplaces like research facility laboratories would probably need to be located underground, with metal radiation-proof construction fortified by the use of compacted in situ regolith. While evidence suggests that solar and cosmic radiation may pose a hazard to astronauts during transit to Mars, recent data gathered by the Mars Science Laboratory indicates that the normal level of radiation on Mars' surface is about what is present in the International Space Station. However, surface radiation could jump to dangerous levels during an X-class solar flare directed at Mars. As shown in this slide from a NASA publication called Space Radiation Cancer Risk Projections and Uncertainties, dated 2012, cancer risk due to radiation exposure diminishes with the age of the person when exposed. This may suggest that until improved shielding is developed for spacecraft, only adults should make the journey to Mars. Due to increased risk of serious birth defects through irradiation of reproductive eggs in female astronauts, much like radiation therapy does in female cancer patients, only women past childbearing age or women who do not plan to give birth to any more children should attempt such a voyage until more data is gathered as to the precise nature of the dangers. Could we see slide 11, please? Underground living quarters would help moderate the risks of both radiation and extreme variations in temperature between day and night. Links to this and other scholarly papers referenced in this presentation will be posted on my website. Because the climate in the equatorial zone is relatively moderate by Martian standards, with temperatures ranging from 20 degrees Celsius in the daytime to minus 73 degrees Celsius at night, this will likely be the location of a Mars settlement. The equatorial zone would also be advantageous for obtaining energy from photovoltaic cells, as they could easily be designed to follow the path of the sun across the sky, as it would never be more than 28 degrees below directly overhead at noon. In addition, an equatorial location would gain the maximum radial velocity from the planet's rotation for return flights or shuttles to possible orbiting fuel depots. Let's try slide 12, please. In one of my novels, I placed the first settlement on the floor of Nicholson crater. Being well below the Mars equivalent of sea level, which I believe is determined by an average of the relative altitudes of Mars' surface features, the atmosphere is a little thicker and therefore a bit warmer than Mars' average. It is also located exactly on the equator on the very southernmost edge of Amazonas Planitia, which is Latin for the plain of the Amazons, named so of the fact that it is one of the smoothest stretches of land on Mars. On this map, you can see Nicholson as a blue circle with a white arrow pointing at it. Let's take a look at slide 13, please. On this larger map of Mars, you can see where Mars Amazonas Planitia is located. Look for it on the far west of the map, just above the equator. Let's try slide 14. Due to the radiation exposure issues mentioned earlier, future Mars settlers would spend the vast majority of their time indoors. A good comparison of the living habitats of Mars colonists would be to how most modern urban residents in the developed world live. The average urban office worker in New York briefly walks from his or her climate-controlled apartment building to the bus or subway, travels to a destination, and then is outside again for only moments before entering an office building. Similarly, a suburban factory worker might go directly from his or her kitchen to a garage-parked car, travel in his climate-controlled vehicle to the factory, and then be outside only for the short time it takes to walk to the door of the plant. Considering these examples, I anticipate that the life of a Mars settler would not be much different than that of most city dwellers here in the United States. As shown in the illustration from one of my books, to provide for more home-like conditions, the walls of the underground habitat could be equipped with LED screens designed to look like windows. The screens could receive a signal from a camera on the surface, showing what the view would be like were the full window actually on the surface. Slide 15, please. As I mentioned, on Mars, surface temperatures range from 20 degrees Celsius to minus 73 degrees Celsius. That means there will be plenty of warmth during the daytime in the form of solar rays. Energy then for the settlement would likely come primarily from a very large array of photovoltaic solar panels. Lithium-ion batteries and fuel cells could store energy gathered during the day and supply the settlement with power after dark. I suggest having both storage systems for redundancy. This arrangement could also be backed up by a small, possibly isotope decay type nuclear power plant for use in the event of the failure of one or more of the primary systems. Overdesign and redundancy of all electrical and mechanical systems is crucial, as these systems are essential to survival. Without the heat and air provided by electrically powered systems, the settlers could not survive long. In my 2010 novel, The Man Who Conquered Mars, I described the layout of such a settlement, along with a description of its food and power sources. This is a quote from my book. The station was laid out in the approximate shape of an X, with 4 arms radiating from a central hub of structures, each consisting of a long mound about 2 meters wide, 1.5 meters high, and 150 meters long. These arms were the tunnels that connected the habitat to each other and to the central structures. Because the habitats themselves were all buried, they appeared only as raised ridges of Martian soil 10 meters wide and 3 meters high, and 25 meters long, arranged perpendicular to the arms like the steps of a telephone pole. 10 habitats were located along each arm. Each pair of ridges had a greenhouse located between them. At the point where the arms of the X met were located the larger underground structures of the community room, laboratories, workshops, and garages. The town waterworks and well were located between the 2 southern arms, and just east of the crossing point was the nuclear power plant. On the east and west sides of town were the solar arrays, each covering several acres. This is just a suggestion as to what such a colony would look like. Let's take a look at slide 16. This one concerns groundwater. Food and water are basic necessities for any traveler. The water well is mentioned in the quote because water will be essential to establishing a permanent settlement on Mars. As I pointed out in one of my Space.com articles, since water exists only in traces in the atmosphere and soil, and as ice in the polar regions during the long Martian winters, the next most likely place to look for it is underground. Since the ambient temperature, even in the equatorial Mars, is minus 27 degrees Celsius, it probably will exist in the form of permafrost. Such water might be harvested through a process similar to the fracking procedure used for natural gas mining here on Earth. Once underground fractures are created with explosives, warm water could be pumped into them, melting the ice. The mixture, probably briny and impure, would be pumped out, filtered, and distilled. With 95% recycling, a level Similar to that currently achieved on the International Space Station, ample water for a settlement could be made available. Let's try slide 17. This is a map of the Sinus-Sebaeus region of Mars. In a 2010 paper published by David A. Sheehan in the journal Geophysical Research Letters by the American Geophysical Union, Sheehan presents convincing evidence that ice is present in significant amounts in several of the deeper craters in the equatorial region. Should this be the case, and proven by ground-based examinations, one of those would be a logical place to locate a settlement. However, if no groundwater is available, the 2% water content detected in the Martian soil by Curiosity could also be used. The soil could be mined robotically, heated to boil out the latent moisture, and then condensed and filtered for drinking. However, I'm betting on frozen groundwater being available. Food shipped from Earth would be prohibitively expensive, so mid-century settlers would have to grow their own, probably using hydroponic farming in pressure-sealed greenhouses. Sunlight on Mars is about 40% as intense as that on Earth, but because the Martian atmosphere is so thin, it should be more than sufficient to power photosynthesis. The transparent panels of the greenhouses would need filters to eliminate harmful levels of ultraviolet and other radiation, and could be made opaque in the event of a solar storm, as well as at night to retain heat. A settler's diet would probably be largely vegan, with meat substitutes and other types of meats that could be synthetically created. The hydroponic farms will have the added benefit of generating oxygen for the settlement while consuming the carbon dioxide generated by the settlers. Let's try slide 18. To perform work duties, astronauts will sometimes need to go outside. For a Mars settler, donning a pressure suit prior to going outdoors may become as routine as it is for a Laplander to put on a parka, snow pants, and boots before going outside in the winter. In my short story, Tenderfoot, I describe a mid-21st century pressure suit. They were already wearing their inner suits, which were the form-fitting garments that protected their skin against the low atmospheric pressure of Mars. Their helmets would each seal against a ring that was located at the top of the inner suit and rested near the collarbone. The outer suit, while also sealed, would not be pressurized so as to remain flexible. It served principally as insulation against heat, cold, and radiation. In addition, it provided a tough skin of protection for the more fragile inner suit. While this may sound unbelievable, MIT scientists are currently working on and have largely perfected a suit similar to what I describe as the inner suit. Let's see slide 19. Here on this chart, we see there's a direct correspondence between the time of day, the density of the atmosphere, and the radiation level on Mars' surface. To reduce exposure, it may be advantageous for astronauts to limit their outdoor work activities so as to avoid mid-afternoon activities when it appears to be peaked. Early morning, late afternoon, or even nighttime work schedules would be best, with crew sleep schedules overlapping primarily in the middle of the day. Slide 20, please. Since working in pressure suits is inefficient and potentially hazardous, the operation of robotic construction and maintenance equipment will feature prominently in the skill sets of Mars settlers. Indeed, such remote-controlled robo-workers may allow the construction of habitats and support machinery prior to arrival by the first Mars settlers. However, I suspect most robotic tools would be more job-specific rather than in the humanoid form of the one pictured here. Let's see slide 21. To travel across the surface of the planet, The settlers will use rovers similar to Curiosity. These vehicles will have mechanical arms with hands so that the occupants can perform tasks outside without leaving the cabin. The Mars Science Laboratory, currently exploring Mars, as well as the deep water robots that repaired the oil well blowout in the Gulf of Mexico while beneath nearly 2 kilometers of water, are prototype examples of these kinds of telerobotic machines. I described the use of such a vehicle in The Man Who Conquered Mars, as depicted in the illustration shown, where the rover's wings are not yet fully deployed. The rover consisted of a flattened cylinder 2 meters high on the inside, 3 meters wide, with a bunk on either side and a storage area toward the rear, with a rounded plexiglass window ahead of the controls, which were located in front of 2 bucket-style seats. Above and below the bunks were mounted the oven, refrigerator, and storage bins. An airlock was positioned at the rear, with more outside storage on either side of the external door, as well as along the sides of the vehicle. 8 meters long from bumper to bumper, the rover was supported by 6 tired wheels, each with its own suspension and steering system driven by an electric motor. Power came from a combination of 60 square meters of solar panels arrayed above the roof like giant wings, storage batteries, and a fuel cell. The fuel for the cell was regenerated using electricity from the solar panels when the cell was not in use. This is simply a suggestion, again, in one of my science fiction stories. Let's try slide 22. So what is the business model for settling Mars? If a Mars settlement is to be economically sustainable, it must find a way to earn its keep. I suspect the mid-century settlement will be organized as a non-profit foundation, much like a college or university. During the early construction phase, it might be funded by the sale of bonds, which the USA, ESA, and other government entities could insure. It will then be sustained primarily by endowments and grants to do research. Secondary sources of income will be revenue from product endorsements, reality programming, educational programming, interviews, the export of small novelty items, and so forth. If some UN treaties are reworked to better support commercialization, revenues might also be obtained from the sale of mineral rights, tourist concessions, commercial land development, and real estate grants. There may also be income from new products and inventions that are discovered by researchers because of their unique location on Mars. There have been several proposals and studies done on how best to provide logistical support for a sustained presence on Mars. One 2011 proposal by John K. Strickland, as presented to the International Space Development Conference, calls for the establishment of fuel depots in low Earth orbit and in low Mars orbit. The problem of ridding the spacecraft of unwanted velocity upon arrival at Mars is solved by an aerobraking maneuver that leaves the spacecraft in a circular equatorial orbit at about 400 kilometers at altitude. The methane and oxygen propellants for the Mars depot would be generated on Mars using native water and carbon dioxide, a concept similar to that proposed by Dr. Robert Zubrin in his Mars Direct proposal. The fuel would then be ferried to the depot by reusable shuttlecraft. This is but one idea. There are others, such as Mars Direct, Mars One, as well as more exotic ideas that utilize Vasimir-type plasma propulsion systems, solar sails, ion propulsion, and so forth. In my view, the winner of the proposal contest will be the one that can deliver cargo and crew to Mars reliably at the least possible cost, and most importantly, can put together the financing. But who will these Mars settlers be? These people who are willing to make a one-way trip to a distant planet. Probably just the sort of people who make up the most qualified volunteers for the Mars One project. Scientists to do research and get the grants to do that work, pilots to fly the spacecraft, engineers to discover and create solutions to the inevitable physical problems that will arise, and technicians to improvise and keep the machinery of the settlement running smoothly. You can go to the Mars One website to review their list of preferred qualifications. Not incidentally, a fair balance of families would eventually be necessary in order to create new Mars settlers in situ. How the settlers organize their families will be interesting to observe. Life on Mars at mid-century will not be glamorous, but neither was life in the settlements on North America during the early colonial period. To date, the 200,000 people who have volunteered to participate in the Mars One project are from over 140 countries, many of whom are scientists and engineers. Take, for example, these 5 candidates who describe themselves in their online portfolios. Mariana is a female graduate student at Harvard University studying chemistry and microbiology. Max has a triple bachelor's degree in engineering, physics, and astronomy, and is pursuing his master's in aerospace engineering at Purdue University. Rod is already ahead of the game in terms of NASA astronaut-type training by being an instrument-rated pilot and scuba diver. Oscar is a U.S. Air Force Academy graduate, licensed pilot, trained to work on nuclear power, and has conducted research at NASA. Carlo is a theoretical physicist. Amy is a female engineer who is currently employed by a NASA contractor. These highly qualified applicants indicate that despite a few crackpots who might apply, there are serious folks who feel that being a true pioneer is worth some hardship. Some of these candidates can be found online in a Facebook group called the 1058, as well as several other such groups. One thing is also certain. Within a generation, it is unlikely that even a small society on Mars will resemble anything we have here. For one thing, I suspect that racial, religious, and ethnic distinctions will largely disappear out of necessity. I will quote one of my characters in my short story, Tenderfoot. He's speaking to a teenage newcomer to Mars. Mars settlers come from all over Earth, from Mongolia to Patagonia, from New Zealand to New Brunswick, and everywhere in between. We try our best to avoid making distinctions about people regarding race, religion, ethnicity, social class, and such. Those things are a source of so much divisiveness and conflict of Earth. We are just too small to dwell on our differences. When I left Earth, I was a middle-class African-American Baptist, as well as a United States naval officer and mechanical engineer. Suppose I only made friends with people like me. I'd be pretty lonesome, as I'm the only person on Mars who's a member of all of these special little groups. Let's look at slide 23. Now, all of this sounds really great, but what if there's an unknown hazard or hazards on Mars that would make settling there more difficult than it appears, or perhaps even impossible? For example, we know from sampling done by Curiosity that there are perchlorates present in the soil. While these could be a valuable resource, they could also be hazardous. Despite being corrosive, these do not seem to have adversely affected Spirit and Opportunity, nor have they affected Curiosity. But those are machines, and Mars dust is ubiquitous. It is hard to imagine how a person can get out of a dust-covered pressure suit without washing down the suit first to avoid inhaling the dust upon removal. Again, this suggests that a plentiful supply of water will be essential. While perchlorates could pose a health hazard, it is also possible that other, even more toxic substances are present in the soil that might make the environment much more hostile than it appears at first glance. Another possibility is the long-term physiological effect of Mars' weak gravity field on the settler's skeleton, musculature, circulatory system, and very importantly, the reproductive process. Our bodies adapt quickly and well to new conditions, and I strongly suspect that after several years of living on Mars, return to Earth would be extremely difficult, possibly fatal. Similarly, Mars-born children will likely be much lighter framed and muscled as they would have lived their entire lives in a 38% G environment. Only time will tell if this occurs and if it's a good or a bad thing. These are a couple of possible, as yet unknown hazards that could face future Mars settlers. There will be more, because as scientists and science aficionados, you are all aware that the number of unknowns always exceeds that of the knowns. Thank you, ladies and gentlemen. If you'd like to know more about Mars colonization and keep up to date on progress on Mars issues, please visit my website at www.dougturnbull.com. And if you enjoy science fiction, you might like to read some of my novels and stories, which can be purchased on Amazon.com. At this time, I would like to open the floor to questions and comments from the audience.
One from here. You'll have to repeat this.
Hello, this is Turnbull.
Yes.
My name is Marty. I live in Maui here. And I'm wondering, I see
Marty asked if the advanced laboratory setups, and I think he's probably referring to the analogs like the Mars Desert Research Station and the station up in Canada. If anything like this was done before the missions to the moon, and I've got to be frank, I know they did a lot of rehearsals. But I don't think they did this type of research because the lunar missions were not planned to last that long. The longest ones only lasted, a little over a week from the time they launched until they splashed down. They only spent several days on the moon. So I don't think they did this type of analog research, which is the direction of this type of research is to try to identify as many problems as they can before we ever actually make the trip. And I hope that answers your question. Yes, I saw that. Yes, I'm assuming that there's underground water. The question was, you're assuming that there's underground water. What if there isn't? If there isn't, it's certainly going to complicate matters. One obvious solution would be to locate your settlement either near the North Pole or the South Pole, where you do have ice present in the winter, so you could get some water that way. Unfortunately, the climate is not too favorable in those locations, especially in the winter. The sun goes down and it stays down for several months, and it gets very, very cold, particularly at the South Pole. Another solution is we did discover, Curiosity discovered that the Martian soil is about 2% water. Now, that's not a lot. That's not exactly soggy, but it's enough that if you were really set up for it, you could heat that soil and boil the water out of there and then out of it, and then condense it and use it that way. Groundwater would be a lot better. It'd be more plentiful. the more the merrier when it comes to water, because we're going to be using it for all sorts of things. But those would be possibilities that I can see in any case, if there's no groundwater available. And somebody asked a question, but it disappeared on me. I can't. It disappeared while I was still talking. That'd be great. Yes, the question is that given that resources on Mars are far more limited than they are anywhere here on Earth, people, how are people going to approach these limitations? And I think the answer to that one is that they're really not as limited as they would appear. We're talking about a planet that has a surface area equivalent to the land area of this planet. The fact that there may be considerably less water does not mean that it is that there isn't enough for a colony to use. We have huge oceans full of water that is simply not used. I used to live in Kentucky. Kentucky utilizes 3% of the water that falls on Kentucky. So the resource limitation I don't think is that serious of a limitation. And as to what Mars settlers are going to do, it's kind of hard to predict what they're going to do. They're going to be doing a lot of new things and probably inventing things that we haven't thought of simply because they're looking at the world somewhat differently than we are. That would be how I'd answer that question. Sure. I haven't heard anything recently about the Analog Lunar Research Park in Hawaii. Is that still an active program? And the answer is I don't know. I know that they kind of wrapped up their one experiment that ran for about 3 or 4 months last summer, and they did quite a bit of research on I think mainly on one of the things they did research on was food storage, that sort of thing. But whether they're going to open it back up again, I don't know. In fact, on my radio show, I wanted to get a lady who was on that experiment on my show, but she declined because I wanted to ask her just that sort of question. Let's see, this is pretty much the same question. Given that resources on Mars are far more limited than any area on Earth, how many of the 200,000 Mars One people are interested in living on Antarctica? My guess is not many. Well, you're probably right that not many, that most of the 200,000, actually they've eliminated 99.5% of them already. The Mars One team has. They're down to about 1,058 of them. And I've interviewed several of these folks and chatted with quite a few more. And some of them are pretty serious folks. They're looking at this as a tremendous opportunity to explore and do things that have never been done before. And I don't think that the hardship of living in an Antarctic type environment is going to be daunting to those folks at all, because they'll be more interested in the science that they're doing, or simply the fact that they're pioneers and that they're doing something that's never been done before. I have a feeling that the final 24 to 40 people that they settle on for the first few missions will be some pretty serious folks that are not going to be easily discouraged by a few privations. That's a good question. Any plans for taking animals to Mars? You know, I just wrote an article recently on space.com where the animals that were taken to Mars were grasshoppers that they would use for food. And because they're very efficient at converting vegetable matter into animal protein, much more efficient than, say, beef cattle, over 5 times as efficient. And they're easier to transport. But I don't know of any plans to take animals to Mars. Not at the moment. Right now, that's certainly a concern. I interviewed Dr. Penny Boston, who's a speleologist, that's a kind of a cave explorer and expert, and she has discovered all sorts of life in caves and caverns that people really didn't even know was there. And one of her concerns is the possibility of accidentally inoculating Mars with life forms from Earth that would have a deleterious effect. Do we know if there are underground water supplies from rovers' presence? No, we don't. The rover hasn't been able to determine it. What is making people suspect that there's underground water actually have been radar studies that were done by orbiting satellites. I think one of the I cannot remember whether it was a NASA satellite or a European Space Agency satellite that did this particular research, but it was radar, a radar survey that led them to believe that there was actually groundwater under the surface of Mars, which would be a boon if we're going to settle there, because then we'd have access to water and probably plenty of it. Any other questions? Any comments, criticisms? There's certainly been some. You just know, one of the people just noticed that there have been reports of possible liquid water seepage on the surface, and there have been some photographs taken that would certainly suggest that there were occasional outcroppings of liquid water. How long the water wouldn't stay liquid very long on the surface of Mars. It would probably immediately turn gaseous and go into the atmosphere. I doubt if it'd even have a chance to freeze. But there have been a couple of photographs that I've seen that just really suggest. I know one series of photographs. One had been taken several years before, so that they knew that this outcropping was a new phenomenon. In other words, it had happened just recently. This wasn't ancient water we're talking about. The question was, as you mentioned, someone born on Mars would probably never be physically able to come to Earth. Do you think Mars will eventually become a totally separate civilization? I think it probably will. It won't be, intellectually, it won't be entirely separate, because we'll always have communication and so forth. But physically, the folks living on Mars will be living in a different physical environment. They'll have a different set of life problems to deal with. They will be remote from Earth. They will probably find Earth's politics, who knows, kind of disgusting, like a lot of Americans. say 100 years ago, regarded European politics. It seemed like it was just an endless bloodbath over there. That was before we started to get ourselves involved in it. But I suspect that it will evolve into a distinct civilization that will look different than our civilization. The art will be different. The literature will be different. Their way of looking at things will be different. And there'll probably be lots of scientific innovation going on simply because they're looking at the world by standing in a different place. And they'll see things from a different perspective. So yes, I think it will be a separate civilization, particularly when you start getting into the second and third generations. They're not going to feel any kind of kinship with us at all, with the people here on Earth. They really won't. Any other questions or comments? Well, that's an interesting question. How many other countries are trying to get there? How many other countries are going to going to Mars? Well, the answer is that so far the only suggestions that I have seen for an actual Mars mission, and this would include Inspiration Mars, and this would include Mars One, and probably include Dr. Zubrin's Mars Direct program, have been international. In other words, they're not really USA, NASA type projects at all. NASA's not doing any of them. If they're going to be done, they're going to be done by possibly a consortium of investors. Some of the space agencies may pool their resources, because I'm just thinking that no one space agency wants to risk that much money on a mission to Mars, but they'll risk, investing in part of the cost. So whether it's done by a private foundation or a consortium of space agencies, or a consortium of space agencies and private ventures, I seriously think is going to be an international effort, because there is no single space agency, not Roscosmos, not the ESA, and not NASA, that are actually talking seriously about doing a Mars mission. All we hear out of Washington is some chatter about maybe doing something in 2035. Well, why not 2036 or 2038? I mean, anybody can name a date that far away. It means nothing. There was another question that disappeared on me after that one. Can you imagine any way this rocket launch would not involve fossil fuels? I'm battling crude by rail here, and I need to see an alternative. I think that in the near term, fossil fuel launches are the only way to get us into low Earth orbit, which is where we have to be. Robert Heinlein, the science fiction writer, said if you're in low Earth orbit, you're already halfway to anywhere, and that's true. But nobody is going to allow any sort of nuclear-powered rocket to take off from the surface of the Earth. The politics of it is just impossible. It just will not happen. It's hard enough to get people to agree to allowing any type of nuclear material to even be launched into space. While getting to low Earth orbit is almost certainly going to be the purview of chemical rockets of some kind or another, uh, after you're in low Earth orbit, then possibly nuclear powered plasma type rocket or ion type rocket could be used to get to your destination, whether it's Mars or an asteroid or the moon. But certainly there won't be any kind of nuclear power, which is the only thing that I can think of offhand that could possibly be used to launch off the surface of the Earth, other than chemical. So it looks like we're pretty much wedded to chemical rockets. Now, whether we use the ballistic type rocket or somebody develops something like the some combination of air breathing craft that gets you to the high altitudes, and then the rocket kicks in and eventually takes you to low Earth orbit, that's hard to tell. Whether we're at the current time using the most efficient means of getting to low Earth orbit is pretty arguable. I know that Elon Musk's outfit, their SpaceX, is talking about reusing the booster rockets, which would be a good idea if it turns out to be practical, because it saves resources. Now the question was, what are these Mars settlers going to call themselves? Are they going to call themselves Martians? I don't know. That's a good question. I doubt seriously if we're going to get the choice. I think they'll make the choice, and as to what they decide to call themselves. Somebody suggested Barsoomian, which of course is let's see, it was the guy that Edgar Rice Burroughs wrote those, I think it was John Carter stories about his adventures on Mars. Any other questions or comments? If I didn't acknowledge a comment or a question, please repeat it. Well, thank you. Thank you for your time. Somebody just thanked me for my time. I thank all of you who listened to this for your time. I appreciate it. Well, I hope it